What's going on, smart people? Today is Tuesday. It's about 8 a.m. I'm about to go with Kelly to class. All I have for the day is statistical mechanics, and today really is all about statistical mechanics because I have my midterm on Thursday. I've been studying a lot for it so far. I have a pretty cool little table of contents that I've made since it's an open notes test. I'll probably show that later on today, but for now, let's just get to class. Also, be sure to leave a like if you're gauge invariant. What'd you guys think about how long we spent in StatMech talking about the gamma function and the Riemann zeta function? I thought it was pretty cool because I was completely ignorant, except for Krishna's taught me about the gamma function a few times, but before that I really didn't know about it. But then we talked about the zeta function, which you guys have probably heard of before, where it's that famous sum over the natural numbers gives minus 1 over 12. He kind of just said that, and then we moved on. I was like, wait, no. How do you know that? Why does that happen? But apparently it's super useful in the theory of different types of gases, Bose and Fermi gases.
Black-body radiation.
Black-body radiation, so I guess we'll be getting into that shortly. We also got a rough idea of what our exam will be on Thursday in just a couple days. We more or less already had a good idea of what it was going to cover. Here I have my little table of contents. Basically everything here up to theory of simple gases. So we've got ensemble theory, canonical ensembles, partition functions, grand canonical, quantum statistics a little bit, except for we're not getting into, we don't have density matrices on the exam, and then all of this stuff on the theory of simple gases, which is like the most. So our professor said that this midterm is going to be open book and open notes and 3 questions. And since it's open notes, I spent a lot of time developing this little table of contents for my own personal notes, and it's very specific. It's not just like grand canonical ensemble starts here. It's for the grand canonical ensemble, mean square fluctuation and the energy in terms of canonical ensemble term plus the correction is on page 32. So I think that's going to be very helpful in finding specific things. More so than, say, maybe looking through the book, because my notes basically are the book, but except for it doesn't skip out on the from which it follows that I go through the derivations. So I think this is going to be really helpful, a speedy process, because I have this professor for classical mechanics, and it's very easy to waste a lot of time flipping through your notes trying to find the right section. But at the end of the day, that's all useless if you don't know how to actually solve the problems in the first place. So the plan is to go through the old homeworks as if I'm taking a test that is the homework and just use my notes as a reference. I think that'll only get me so far because since I've solved the homework, I kind of know what the tricks are to them. So in the process, I think it's helpful to kind of think of, well, what other questions that could you ask that are still on topic to that homework assignment? You know, because you could lie to yourself and be like, oh, great, I understand the homework that I've already solved and solve the solutions to. So, you know, make sure that when you rework your homework, you're not just fixated on those specific problems, but that's pretty obvious. I actually decided, and I should have decided a while ago, that instead of just memorizing or jotting down the different relations for combinatorics for different microstates, that I take the 10 minutes that it takes to take it by case scenario and say, if I have this many particles and they can be in these 2 states and there are this many, how many microstates are there, just to make sure that I know how to derive the combinatorics if I need to, and even that helped a lot. It was so nice yesterday. Now it is 41 degrees in New Mexico. It is Wednesday morning. It's 8 a.m. I have class in an hour. This is one of those days where I have to be on campus until like 3 p.m. and then I get to come home and finish up my studying for statistical mechanics. I feel like I'm getting a bit of a cold, and I hope I'm not, but I guess we'll see what that leads to. Yesterday, I put out a post in the community tab saying, give me questions and stuff to give all these physics grad students in the department, and we'll read them. I probably should have waited a little bit to post that in the community tab because it already has like 120 questions in it, or 120 comments in it. So there's probably no way we're going to get to all of them, and I'm not going to put them all into this vlog. I'll probably put some of them into the vlog and then the rest in a regular video. So I think that'll be the best way to do that. That way the vlog isn't like 40 minutes long. But yeah, it's time to go to class. I have quantum mechanics, then quantum field theory. Super stoked for quantum field theory today because today we finally get to quantum electrodynamics. We're going to be making Feynman proud. So it looks like for the Q&A, we've got Abhishek for a while, and then we're going to have Andrew. Krishna, are you going to be in the Q&A?
I'm not sure.
All right, Krishna's a maybe. Sharad?
What is that?
Sharad's a maybe. And then Nirajan, he has a lab when we're planning on doing the Q&A. So I'm thinking afterwards, after tutoring, I might come back, and if there's any like specific questions or interesting questions that were left out, me and him will have a little duo sesh with all these questions. There's over 120 so far, so there's no way I'm going to get to all of them. I don't think, anyways, because that sounds like it would take a long time, especially if a lot of people are talking about it. But I guess we'll see. I think in the meantime, we're probably going to be studying for our stat mech midterm, which is tomorrow. We just spent a good amount of time kind of BSing and going over combinatoric stuff, but I think it's starting to make sense now. I'm not as worried about the stat mech exam as I was about the previous classical.
Which is always a good thing, right? Yeah. Confidence in an exam is wonderful.
Yeah. How are you guys feeling so far?
I'm not confident, but we'll see.
Well, you still got almost 24 hours.
Almost, yeah.
But you have a check.
I'm 60-40.
60-40. So home now. For QFT, I said that we were getting into QED. We really barely scratched the surface. Today we more or less just talked about charge conjugation and the electromagnetic field Lagrangian, where we wanted to show that it's invariant under certain gauge transformations. I think that's what we were doing. I'm still a little fuzzy on everything because it's pretty new to me. But it seemed like we introduced the covariant derivative, and then we transformed our field and our A mu under this gauge transformation, and we showed how if our covariant derivative acted on it, we had something that's still invariant. I haven't gone through the math to see invariant under what, but I think it's under local gauge transformations. I'm assuming since you're contracting the covariant derivative with like the gamma matrix that it's also going to be Lorentz invariant. I think it has to be. But we threw the word invariant around a lot under that, and I wasn't sure under what group of transformations. That's probably a question I should have asked. But I'm sure by the time I post this video, I'll figure out what it's invariant under. It's a cool topic. It's a little there's a lot of gamma matrix manipulations. We're getting into the nitty gritty. I'm excited about it. So we should spend about 3, maybe 4 lectures on QED after this one, and then it is my turn to talk about non-abelian gauge theories, where I'll be talking about the group theory associated with that, and then probably a good part of the lecture will be on QCD. The way that my professor has us doing is basically understand as much as we can, take notes on it, be prepared to lecture on all of it, get 1 full lecture's worth. If you would like to, you can do the next lecture too if you have enough material for it. So I would like to get to QCD, but I think that there's so much material on non-abelian gauge theories in general that I could cover first before even giving an example. So we'll see how that goes. But it is 4:22. I'm going to spend the rest of the day studying for this stat mech exam, which is tomorrow. I'm feeling pretty good about it. There's one thing that I still need to emphasize a bit more, and that's partition functions for classical systems. Because for quantum systems, you typically just sum over something that's basically the exponential of the Hamiltonian times some stuff, and that gives you your partition function. You can tailor that to more specific cases, but for the most part, that's what you're doing. But for classical systems where you don't have discrete energies, instead of a summation, you get this integral over all of phase space. So that's an integral over all of your dimensions of your coordinates and all of your dimensions of your momenta. And just that I'm a little bit uncomfortable with still. So I need to emphasize that a little bit before I feel good for this exam. And then I should be good to go. So I'm going to get back to studying. This might be the last clip of the day. If it is, sweet dreams. I love you, and I'll see you tomorrow. Okay, it is Thursday. It is about 7:48 in the morning. My midterm is in a little bit over an hour. I've been up since about 5:30, getting some last minute studying done. I feel pretty good. I don't think that there's any little pockets of information that I've just missed out on with studying, and some of the subtleties, I know exactly where they are in my notes since this is an open book test. I don't know why I keep mentioning that. You guys already know this. So I feel as prepared as I could be for this test. As always, you could always throw some curveball problem that I just don't know how to solve. But as far as reasonable problems go, I feel pretty good. Whether that's for classical systems or quantum systems, Bose and Fermi-Dirac and Maxwell-Boltzmann and the limiting cases of them, counting microstates, finding different types of partition functions. I feel pretty good about doing all of those. So the test, like I said, is in a little bit over an hour. I guess Kelly and I are about to Uber for hopefully the last time to class today, because I got the phone call yesterday from the dealership saying that they will give me a rental car until my car is done. So that's pretty good news. You guys are ready for this exam?
Yes.
Pretty much, yes, man.
You excited? I'm excited.
I'm pretty much excited.
This is the group. This is the squad that's also going to be doing the Q&A, I believe. More plus or minus a couple people. Brought in the special tripod just for it. Let's go take this exam. It's going to go so well. Just got out of the stat mech exam. I think more or less the consensus is it went.
Okay.
It went okay. It went.
Yeah.
It went. It went okay.
Things happen.
We'll find out next Tuesday probably how it all objectively went.
What about you, Andrew?
I think it went okay. It's just there's a level of confidence that's missing with certain ones of those problems.
I mean, you give.
Like number one I think is fine. Two, with the number of microstates, it's like I haven't convinced myself, because there's basically two schools of thought of what the number should have been, and I need to look into it more to be like, am I wrong or am I right, or are we calling things different things? But now we're about to get to going to those questions that are posted in the community tab. So let's get to that. I think we're just going to set up a desk, and then I'm not going to answer all of them in this video, not even close, so it's going to be split into multiple videos, I think. Probably I'll put them out for the 30,000 subscriber special or something like that. So let's get started with that.
Andrew is racist.
It's recording. What's going on, smart people? I put up a poll on the community tab saying, what questions would you like to ask grad students? Some of these questions are going to be addressed in this weekly vlog. Most of them are going to be put in a separate video, which will be up for the 30,000 subscriber special, if you want to call it that. So I have a bunch of our fellow grad students with us today. Everyone want to introduce yourself? Where's my coffee?
Hi, I'm Elijah.
Hi, I am Abhishek.
I'm Andrew.
Hi, I'm Krishna.
Hi, I'm
Okay, good. Yeah, I figured you guys always hear what I have to say, but it'd be nice to get the different grad students' perspectives for all of your questions. Is it ever intimidating knowing all the great minds that have come before you in physics? So just being surrounded by smart people. You guys find that intimidating?
I'd say, not necessarily intimidating. It definitely makes our work harder because, like, most of the low-hanging fruit has been picked and eaten already. So you have to really search for the new science. And it basically, we have all these cool tools that make it so much easier with our high computation power and everything, and all the knowledge of all those great minds that they found. But we have to work a whole lot harder to find anything new.
Oh, I read the question wrong. I thought it was being like, you're in
Like your
grad school next to
professors.
smart people.
Yeah.
Is that...
No, they mean
no.
like, does it intimidate you knowing Newton and Einstein existed?
Yeah, and at the same age, they were
Yeah.
doing all their amazing
Yeah,
things,
like
basically.
for like me, it's not that intimidating. It's just I
kind of
know that I'm
encouraging.
not at their level, you know.
inspiring.
It's inspiring.
It's
right?
inspiring,
Yeah,
yeah.
it's
for sure.
inspiring.
Yeah.
Rather than.
Use it as a motivation, not
Yeah,
as something
yeah.
that's gonna drag you down.
What math courses would you recommend for a physics major in undergrad but unsure which area to go into? So I have a comment about this. I think every physics student in undergrad should probably pick up a minor in math, because any check in the list of a minor in math is the basic math that you're for sure going to use in physics, whether that's your multivariable calculus, differential equations, linear algebra. Those are the big ones. And then the rest, you can always benefit from taking like real analysis or, I don't know, maybe like a statistics course.
Yeah,
So
statistics will be better, right?
if you go with getting a minor in math, a lot of the things that you need to have will already be taken care of for you. And any of the more advanced areas of mathematics, like if you're talking about group theory or differential geometry or something, that has a way, or it seems to have a way of sorting itself out in the courses, say in grad school, that you'd be taking that use that. So if you use a new branch of math in a physics course, in my experience anyways, they'll teach you it in the physics as the way a physicist would use it.
I feel like they'll touch on it.
Yeah,
and then
they'll do a 1 week summary of
which is
a
good.
semester.
But the fields that were most important to me was partial differential equations. That was a wonderful class. But
For the mathematics, I have the different feeling. Like, if you ever feel like going in the theoretical physics, do not study mathematics just as a tool. then it's really hard to digest all the stuff. If you really want to be a theoretician, especially in the particle physics, study the mathematics as an whole subject, not just like you will be using it in just physics. No, understand it fundamentally, then the physics will make more sense to you. Because if you look at the last 20 years in the particle physics, most of the stuff they are doing is higher mathematics with a little bit of physics in it. So if you don't know the mathematics fundamentally, you will never be able to grasp all those stuff.
Yeah.
It's like the equivalent of how we always use like residue theorem or something, but that's
Yeah.
always towards the end of a complex analysis book.
Yeah,
There's
exactly.
so much that comes before that.
Yeah.
Okay. Those of you doing research, so singling me out of not doing research, those of you doing research, how did you decide on your research topic, and how do you usually go about doing the research?
Well, I sort of just fell into it. I didn't know what I was going to do after undergrad, and I started talking to professors, and I knew this one professor from undergrad that had some cool posters up and stuff. Just kind of talked to him and was kind of told what to research. And then, like, how I go about it now is in a very unorganized way. Just kind of play around with a bunch of data, and then I like have to present it, and so then I go back and do a lot of literature review to figure out what I actually was doing in my analysis.
So what is your research in?
It's basically materials science using X-rays and neutrons.
All right.
Yeah, well, I did an internship in my undergrad, and one of the professors that I worked with at that internship got a job here. So I just kind of followed suit and followed her here, and that's where I got my research in seismology. How do I go about doing it nowadays? Basically chaotically, just looking into anything and everything. Some days I'll spend a couple hours just looking into how MATLAB works, more special functions that might make my code more efficient. So I do a lot of computational work with seismic waves. So, and then when you have to present, you do a lot of lit reviews so that you understand kind of what's being done. In lit reviews, the people that actually publish papers usually have a really good way of explaining what you're doing, and you just kind of go from there.
What about you guys?
Actually, for my case, the main thing is where you are interested. So actually, are you interested on which kind of field, like particle physics, or in our university we have like mainly two branches of research, like in particle physics, theoretical, and the experimental condensed matter and theoretical condensed matter also. So it's depend on where you interested, so which field you are interested.
Those undergrad projects are a good way of finding out if you like doing research in the first place, too.
Yeah.
Because you might like a topic in physics, but then when it comes down to actually conducting research, you're like, wow, I feel clueless all the time. I don't want to do that for my career.
Yeah, and it tends to be like less pressure.
Yeah.
It's not like you're being paid a lot of money or
Yeah.
something to do that research.
Yeah, it's the best advice.
Good way to test.
As like a freshman, look for research, and if you're not a freshman, don't feel like it's too late. Just find something to do, and see if you like it.
Krishna?
I think it's basically depend on the interest, right?
Sure.
In which area you are interested. So I choose the professors. I was interested in material science. So there is like two options. One is like experimental, and then another is theoretical. And I went to the theoretical part because I was I like to play with the computers, and then my kind of work is like in the computer data analysis and like to find the structures.
So it says, how did you decide on your research topic? So I think the general consensus is like, the best way to try is to either do some research in something, because you can either narrow it down, or you could get lucky and try something and just automatically like it. What about you, Abhishek? Did you already go?
I haven't started research here, but when I did my master's, I did a review project on finite temperature quantum field theory, and then I was looking for the application of those stuff, and I stumbled upon the neutron stars, and that's when I found that nuclear astrophysics is really cool stuff. because it's a mixture of the you need to take care of all the things which you ignore in the quantum chromodynamics. If you have the QCD, you apply that QCD, and then you need to determine at what level the gravity overcomes the QCD. So this was really intriguing, and I find it fascinating. That's why I started with the nuclear astrophysics, and especially on the neutron stars.
All right, so right now I think I have to go tutor now, so I'll probably pick this back up after tutoring with whoever's left. So thanks everyone. If you guys are still here after tutoring or something like that, I know that you have to go to lab.
Yeah.
We'll probably pick this back up, and then I'll find out how to divide this video into probably 2 videos because we've got a lot to go. Okay, so see you afterwards. So I am home now. My camera ended up dying, and I, obviously couldn't record with a dead camera. We spent a couple hours answering these questions. It's definitely going to be split over multiple parts, and we still didn't even come close to finishing them. So I think it's going to be a process of, chipping away at all of these questions over time. So the first part or 2 is more or less recorded, and then we'll tackle the rest, when everyone has time. As for now, it is time to actually record my video for today. Today is Thursday. Since it is 3/14, it's Pi Day. It is also Einstein's birthday. I had bigger plans for what I wanted to do for Einstein's birthday, with this being the funnier video, but time kind of got away from me. So now I think I'm going to see if I can find a cool little Einstein quiz, like something like how well do you know him, or something like that. If it's a fun quiz, we'll take it, and that'll be the video for today. I think it's a little bit excusable with there being a midterm today and all of the other recording we have to do. So let's see if we can find a quiz. I may have spoken too soon. I've made well over 300 videos in the past 2 years, really well over 300 videos in the past year, so the ones that I've made kind of slip away from me, and apparently I already made that video 9 months ago, which is weird because why would I make how well do I know Einstein quiz when it's not even his birthday? So now I don't exactly know what to do. Today is a projectile motion lab, so today the students are going to be working with this thing here, which is kind of like a gun, and it has a little lever and a little wooden ball, and you're going to pull it, and it shoots the ball. The point of the lab is to play with the angle and see how that changes things like the velocity of the ball and the x direction, the height that it reaches, and how far that it goes. And then they're going to be checking their results experimentally with results that you can derive from the kinematic equations, like the range equation. Then towards the end of the lab, the last topic is to give these students like a target that's x distance away, and I will say, find out the angle that you need to shoot this projectile from such that you hit the target by calculating it first and then verifying to within a certain amount of degrees that that's the angle that you need to shoot it from. Of course, there's going to be some error because some of the energy is going to be lost due to friction and things moving. It's not a perfect system. So I will see you after lab. What a week it has been, from having to Uber everywhere because my car is still in the shop, to the statistical mechanics midterm, and then spending hours answering people's questions. It's been a hectic week. By the way, once I get to actually editing some of the Q&A, I'll make up my mind on how many videos of it I want to break it into, because it's a lot of questions for one, so I think people are going to lose interest in watching that many questions be answered. Plus, I haven't gone through them all, so I don't know how many of them are going to be redundant questions, and I think for the most part we got all of the big ones out of the way already, so we'll see. It'll really take actually watching part of the video and seeing how to make a good series of videos out of it. Should I make it into 2 videos? Whatever. I'll decide later on. But the week is finally over. Next week should be a little bit less hectic as far as on-campus things go, because all I have due and going on next week is my quantum mechanics homework is due. That's on the Klebsch-Gordon coefficients. So as far as academic stuff goes, it should be relatively lax. It just means that I have to spend my entire weekend doing quantum mechanics homework, which you're obviously not going to see. So since I was relatively lazy with making videos this week, I want to make up for it next week. So next week should be the tensor calculus next episode, finishing up stuff on the metric before we get to derivatives of tensors. And I'll try to think of something besides like a meme review to do for the more funny videos, because I want to put a little bit more effort into it this week. So thank you guys for watching the video. Hope you guys enjoyed it. Let me know in the comment section if you did. I'll see you guys there.